Okay, now we're going to solve some rational equations, and our rational equations are equations that have these fractions in them. Okay, so these are usually pretty complicated and long problems. Sometimes they're easier than others, but there's a few things that you have to watch out for, but you have to check your solutions. Now, checking is not always easy because of the fractions, so technically what you have to check for are what we call our restrictions. Because of the variables in the denominator, I am not allowed to have a 0 in the denominator. So in this case, I have restrictions that x cannot be 0 because that 0 is going to make this fraction undefined, and x cannot be 3 because it's going to make the second fraction undefined. So I tend to find my restrictions right away, make sure I remember those. So if I happen to get a solution that's either 0 or 3 after going through the whole long process of solving this, I look back and say, wait, that can't be a solution. Okay, so let's go through this. We've done these before, but I need a common denominator. So what is my least common denominator? And some people like to write this over 1. It doesn't have to be set equal to 0. A lot of times in these equations we do not have them set equal to 0. This one in particular does. It will make it a little bit easier, but not a whole lot. So my common denominator is going to be x times x minus 3. So I'm going to rewrite all of my fractions with my common denominator, and then I just need to look at the numerator. So here I'm going to have and I can put this as, oops, this is a minus. I can put this as just 0 over it if I want to. So this is going to be 4x, x minus 3, because I needed both x and x minus 3 here. This one's going to be 12, and then I am just missing the x. And here I have a 10, and I'm missing the x minus 3. So what you'll notice is if I cancel these out or reduce them down, I end up with my 10 over x. If I reduce these down, I have my 12 over x minus 3. If I reduce all of this, I end up with just 4. And this one I could have written, I guess technically I have this. And so if I reduce it, I end up with just the 0. Okay? So I use this method. There are shortcuts, but what I like about this method is now I have an equation where this minus this plus this has to equal this. All of my denominators are the same. When you're adding or subtracting fractions, if your denominators are the same, the only thing we worry about are the numerators, right? We just add and subtract our numerators. So all I have to worry about is this being a true statement. And I'll just put the 0 here because 0 times anything is 0. And now I'd have an equation that does not have any fractions at all. So I'm going to distribute. Okay, let's keep simplifying this left-hand side. So I have 4x squared, and when I combine these three, I'm going to end up with minus 14x, and I have minus 30 equals 0. Okay. So what you're going to notice is that I have a quadratic equation. I have the x squared. I also have an x, so that using the square root property is not going to be an option here. I have to decide, do I want to try to factor it? Do I want to use the quadratic formula? Completing the square, I really don't want to do because of the 4x squared here. So those are really my two options. If I factor, it may be a little faster, but it's also not going to be the easy factoring because of the 4x squared. I'm going to solve this one by factoring. So the first thing I notice that there is a GCF, and I can actually factor out a 2. That'll make this a little bit easier. And so I'm just really looking at what's in here. Now some of you may know that you can actually divide, because I do have an equation. I could divide everything by 2, which also works, but I can just ignore the 2 for right now, and I need to come up with these two factors. So what multiplies to give me negative 30 and adds to give me negative 7, and I come up with negative 10 and 3. So I know I have 2x and x here. So what's going to give me either negative 10 or 3? This has to be a minus 5, so this times this gives me negative 10x. And this is going to have to be a 3, so that this times this gives me the positive 3x. And I know that 3 times negative 5 is going to give me my negative 15. So I use the guess and check method here. If you like to make it 4 terms and factor by grouping, you can still do that. So I now have 2 times the quantity 2x plus 3 times the quantity x minus 5 equals 0. And I can set each of those factors equal to 0. So 2 doesn't equal 0, so I don't need to worry about that one. Here I get x equals negative 3 halves, and here I get x equals 5. Now, neither one of those is going to be one of my restrictions, so I'm good with that. I can go back and try to check these. It's not super easy to check because of the fact that you have to plug them in and you have fractions here, but with a calculator you could do, most likely if you check like the 5 and you factored it correctly here, then negative 3 halves is also going to be a solution. Now, let me just show you, if I use the quadratic formula, at this point I'm going to have x equals my a equals 4, my b equals negative 14, and my c equals negative 30. So I'm going to have 14 plus or minus the square root of negative 14 squared minus 4 times 4 times negative 30 all over 2 times 4. I'm going to do a lot of this simplifying for you here because I get the square root of 676 here all over 8. And then the square root of 676 happens to be 26. And so if I add the 26 and I subtract the 26, I get x equals 5 and x equals negative 3 halves. Okay, both methods are actually good. I don't think the quadratic formula was really that much longer than actually factoring, and I know some people really don't want to have to factor when you have that or that. Here's another rational equation, and notice I don't have it set equal to 0. It's my typical, I have fractions on both sides. I'm going to put this over 1, and we're going to need to find a common denominator again. So if you look, the denominator of this one is already factored for me. If it's not factored, I need to factor it. But I have x plus 3, x plus 3, x plus 4, x plus 4. So my common denominator is going to be x plus 3, x plus 4. Now, the other thing I need to watch out for here, remember, are my restrictions. What can x not be? So if I look at this, I have x plus 3 down here, or I have x plus 3 down here, so my x can't be negative 3, and I have the x plus 4 and the x plus 4, so my x can't be negative 4. So those would be my restrictions. Now, let's just rewrite all of these fractions with my common denominator. And this is just a long problem. So my first fraction, I just actually have 1, so I'm going to need the x plus 3, x plus 4 in the numerator and in the denominator. Okay. Notice if I reduce this, these reduce to 1, these reduce to 1, I end up with 1. Okay. My second one already had the whole entire denominator, so I just leave the 2x. My third one, I'm missing the x plus 4, so I'm going to have to put an x plus 4 in the numerator. And then the last one, I'm missing that x plus 3. So what I always like to do is look, if I reduce this, I end up with what I started with. If I reduce this, I end up with what I started with. But I'm now at that point where my denominators are all the same. And so I only really need to look at the fact that x plus 3 times x plus 4 plus 2x has to equal 2 times x plus 4 plus 4 times x plus 3. And I can ignore the denominators because I have equal denominators. So I just need to simplify this. FOIL this out. Distribute on the other side. And combine like terms. And now you'll notice at this point I have to decide, okay, is it quadratic, is it linear, is it polynomial? And I have an x squared that I can't get rid of, and I also have my x's, so I'm going to set it equal to 0. It's quadratic. So I have x squared. If I subtract 6x from both sides, I get plus 3x. If I subtract 20 from both sides, I get negative 8. Now, is this factorable? Because this could be the easy type with the factoring. So I look at multiply to give me negative 8, add to give me 3, not factorable. So I'm going to have to use the quadratic formula on this one. I could use completing the square, but this is not even, and so I'll end up with some fractions. If I use my quadratic formula, I have a equals 1, b equals 3, c equals negative 8, and I have x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 8 all over 2 times 1, negative 3 plus or minus. If I simplify that all down, I end up getting 41 all over 2. Square root of 41 cannot be simplified, so this ends up being my solution, or my two solutions. Okay. So on these rational equations, one thing to watch out for, remember, are my restrictions. And in both of my examples here, I didn't end up getting a solution that was the restriction, but it definitely can happen. Make sure that you have your common denominator for all of the parts of the equation. So even if you don't have a fraction, you still have to write it with that common denominator. And watch out for minus signs. I didn't have a minus sign in this one, but like if this was a minus, you need to make sure it gets distributed. So like this would be a minus, and that needs to be distributed. It's hard to check your solutions on these, especially when you get a solution that's irrational like this one. But just take your time, be careful, show all your steps, and hopefully you won't make that little mistake that causes you to get an incorrect answer.